All right, folks, so today we're going to talk about the three major trig functions that exist in a right triangle. So here I have a right triangle, and above it I have a word that you're probably wondering what the heck that word is. Sohcahtoa. It's a weird word. It's not really a word. It's actually an acronym. And at the end of the video, hopefully you'll understand exactly what the acronym stands for. So in a right triangle, each acute angle has three ratios that we can write based on the sides. So for example, let's choose angle A here. If we're talking about angle A, the three sides can be labeled, this is the hypotenuse, we know that. And these are the legs. But if we're talking about angle A, then this leg right here is opposite angle A, right? So we're going to call this the opposite side, or the opposite leg, because it's across, it's opposite of angle A. And this leg here is right next to angle A. And another word for next to is adjacent. So we're going to call this the adjacent leg. Okay? Now, if I was talking about angle B, those sides would be labeled a little differently. But for right now, if I'm talking about angle A, this is the hypotenuse, this is the leg opposite angle A, and this is the leg adjacent to angle A. Okay? So, there are three ratios that we can write in relation to angle A. The first one is called the sine ratio, and we abbreviate it SIN. The sine of angle A is equal to the opposite side over the hypotenuse. So it would be this length over that length. The cosine, which we abbreviate COS, of A is the adjacent side over the hypotenuse. So for angle A, that would be this length over that length. Okay? And then finally, the tangent, as we abbreviate it, tan of A, the tangent is equal to the opposite side over the adjacent side. So that would be this side over this side. So if you look up at this acronym, Sohcahtoa, if you can remember that one weird word, that acronym, then you can remember all these ratios, because that's what that acronym stands for. The S stands for sine. Sine is opposite over hypotenuse. The C stands for cosine. Cosine is adjacent over hypotenuse. And then the T stands for tangent. Tangent is opposite over adjacent. So you might be looking at these ratios and thinking, I'm never going to be able to remember that. But if you can remember this one acronym, then you can remember all those ratios. Okay? Now, with that in mind, let's talk about how does this actually work? How do we actually put this into play? Well, let's give these sides some lengths. So let's say, for example, that I labeled the sides with lengths. Okay? So I'm going to go ahead and call this side 3, this side 4, and this side 5, because I know that forms a right triangle. Now, if I wanted to know what the sine of angle A is, the sine of angle A is your opposite over your hypotenuse. So the sine of angle A would be opposite 4 over your hypotenuse, which is 5. So the sine of angle A is 4/5. The cosine of angle A would be the adjacent side, which is 3, over your hypotenuse, which is 5. Okay? And then lastly, the tangent of angle A would be the opposite side, 4, over the adjacent side, which is 3. So these are the 3 trig ratios for angle A in this triangle. So this is what we're going to be doing initially here, just writing the fraction. Just writing the fraction of each ratio for the triangle. And this is what your homework's going to be like. Okay? Now, just in case you're wondering, these ratios are on your calculator. On your calculator, you have a sine, a cosine, and a tangent button. Sin, cos, and tan right there on your calculator. And we're not going to use the calculator for today's assignment, but we will be using it later on. For those of you that might be using your cell phone calculator, the cell phone calculator also has this on it. If you turn it sideways, so you get the more fancy version, you can see it right there. Sine, cosine, and tangent. Not the one with the H attached to it, just the one that's sin, cos, and tan. So we'll be using that later on this week. But for today, the problems are just going to be like this. Okay? So let me change the triangle. And let's see if we can do a couple more examples. Let's say I made the triangle look like this. Okay? And I call this A, and this B, and this C, and I call this 7, and 24, and 25. And now we want to write the ratios here. Okay? So the sine of A, opposite over hypotenuse. So here's A. So now the sine of A is opposite, 7, over hypotenuse, 25. Okay? Cosine of A. Cosine of A, adjacent, 24, over hypotenuse, 25. And lastly, the tangent of A, opposite, 7, over adjacent, which is 24. So it's as easy as that. All we're doing today is getting used to writing the ratios. That's it. Okay? Now, what if I changed, instead of talking about angle A, what if I changed to the fact that I wanted to say, well, what about if we're talking about angle B? What are the ratios for angle B? Okay, so let's change this a little bit. If we're talking about angle B, sine of B, cosine of B, tangent of B. Now, the sine of B, this is the angle we're talking about. So the opposite side would be 24. That's the side across from it. So the opposite side is 24. The hypotenuse doesn't change. It's still 25. But now the sine of B is 24, because that's opposite, over 25, the hypotenuse. Okay? The cosine of B. Okay, so now the adjacent side is the 7. That's the leg next to it. So it'd be 7 over, the hypotenuse is still 25. Okay? And then lastly, the tangent of B. Okay, opposite, which is 24, over adjacent, which is 7. So those would be the ratios if we were talking about angle B. So within one right triangle, the ratios for each acute angle will be slightly different. Slightly different. They are related, but they're slightly different. And we'll talk more about the relationship as we go. Sorry about the fact that the screen just shook. My cat just walked by and knocked the camera there for a second. Okay? All right, I'm going to give you one more for you to try on your own. And I want you to pause the video and try this on your own. Okay? So let's talk about this triangle here. Let's talk about angle A, B, and C. Let's talk about angle A. Okay? Let's call this 6, 8, and 10. Actually, let's change that because those will just reduce. So let's just call it, even though it doesn't look like it, 5, 12, and 13. And we're talking about angle A. So you pause the video for a second and you find the fractions for the sine of angle A, cosine of angle A, tangent of angle A if the sides are 5, 12, and 13. All right, pause the video and do that for a second. I'm going to let my cat out. Okay, welcome back. So hopefully you had a chance to do this, so let's go over the answer quickly. So angle A, the opposite side of angle A is 12, and the hypotenuse is 13. So the sine of angle A would be 12 over 13. Cosine of angle A, the adjacent side to angle A is 5, and the hypotenuse is 13 still. So the cosine of angle A would be 5 over 13. And then lastly, the tangent of angle A. Here's angle A. Opposite side is 12, and the adjacent side is 5. So that should be the ratio. Those should be the ratios that you had. Okay? So this is what the homework's going to be like. This is going to be a bunch of right triangles labeled with the sides, and it's going to give you a trig function like this with an angle, and it's just going to ask you to write the fraction. That's all there is to it. And if you can follow this acronym, that'll help you remember, okay? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, okay? So after watching this video, hopefully this helps a little bit. We're going to spend time practicing this. So work on the practice work today, and then there's an exit ticket for you to do that just has a couple problems on it. All right? Thanks, folks.